Okay, these are your notes for trigonometry, sorry. So, first thing you need to do is always make sure that your calculator is in what we call degree mode. And I'm going to show you how to do that right now. So you obviously open up the TI Inspire app, go over here to the gear on the right side for settings, and then you'll see right here next to angle, it says degree. Mine already has been changed to degrees, but yours should still be on radian. So you want to go ahead and change that back to degree mode. Okay, and then done. All right, so that's the first thing. Okay, once you have done that, let's go ahead and get started. Okay, so first let's talk about what this even is. So the trigonometric functions are sine, cosine, and tangent. So we have sine. Let me highlight these as I go along here. We have sine, cosine, and tangent. The reason that we're going to use these to find missing sides and angles of right triangles. So y'all are probably like, oh my gosh, we are still doing right triangles. Yes, we are still doing right triangles. Get over it. So we use sine, cosine, and tangent to find missing sides and angles of right triangles. So that's the purpose. And sine, we shorten to SIN. No, we do not call it sin. Nobody calls it sin. Well, people that know what they're doing don't call it sin. Cosine, which is shortened to COS, and tangent, which is shortened to TAN. So that's where we get those from. And if you've ever looked on your calculator and you wondered what those were for, we're about to learn right now. Okay, so this is just a mnemonic device to help you remember which is which. SOHCAHTOA. No, never mind. I was going to say something, but I'm just going to keep it to myself. So yes, SOHCAHTOA. It's just a mnemonic device to help you remember. So is going to stands for, sine, of course. Let me just point the arrow. So sine. And then the O stands for opposite. And then H stands for hypotenuse. Okay, for cosine, C stands for cosine, or for C stands for cosine, A stands for adjacent, which is just another word for next to, something next to something else. And then H, of course, is hypotenuse again. And then for TOA, T stands for tangent, O stands for opposite, and A stands for adjacent. Again, adjacent just means next to. Something is next to something else. Okay, now that we've established that, let's get into it. So again, we have used Pythagorean theorem. We have used the special right triangles. Remember those? The 45, 45, 90, and the 30, 60, 90. We've used those things so far to find the missing sides of right triangles. Now we're going to use a third option, which is the trig functions, to find missing sides and missing angles now of right triangles only. Okay, so the first thing you need to do is identify which side is the hypotenuse, the opposite, and the adjacent. So that's the first thing I always like to do. So you should know by now, the hypotenuse is here, across from the right angle. Okay, so that's the hypotenuse. Okay, I'm gonna erase that arrow. So now you need to identify so after you've figured out where the hypotenuse is, ask yourself, say self, what is the angle in question? This is the angle in question. So that's the angle we're focusing on. And then across from that angle is the side we call opposite, because it's opposite of the angle in question. And then next to that angle is going to be the adjacent side, because it's next to the angle in question. So again, adjacent means next to, opposite obviously means it's across. Okay, let me get rid of that line right there. It's getting on my nerves. Okay, now it says to find x. So in order to find how long this side is, okay, it's asking us to find x. What we're going to do is set up this equation here. So sine of A, and A is 37 degrees, and we don't need to put degrees, we can just put 37 equals, so that was sine A, and now we have to do opposite, which is x, right, because it says it right there, over hypotenuse, and the hypotenuse is 5 right there. Okay, so now that you have that, you just need to get x by itself. So first step, set it up, or second step is set it up. The first step is to label your triangle. Then your third step is to get x by itself. So x is over here. Now, actually, I'll walk you through it for this one. So we're trying to get x by itself. So in order to get 5 from underneath the x, we're going to multiply both sides by 5. So multiply both sides by 5 so that we can cancel out the 5s. So now we have 5, I'm sorry, let me get rid of that. So now x is finally by itself, and we are left with 5 times the sine of 37. So we're going to head over here to the calculator and, and I'm just going to get rid of all of this. Okay, so we're going to have 5 sine, and you can see the sine button is right below ABC over here on the left side. 37. There you go. So now that's going to be 3.01, and we're going to round all of these to the hundredths place. So we're not going to use tenths place for this unit. Okay, and I'm sorry. Yeah, 3.01. So the length of side x is 3.01. All right, now we're going to move on to the next example, which is cosine. So again, first thing, identify which side is which. So this side is the hypotenuse. This side, let's figure out where the angle is. So this is obviously the angle in question. And then that's going to be the opposite side of that angle. And this is the adjacent side to that angle. Okay, so now we're going to take this function here, or this formula. This is going to be cosine of A, and A is 53 degrees. Okay, so that's 53 equals, and this one says adjacent, which is 6, right? Because the adjacent side is 6, over hypotenuse. The hypotenuse here is x, right? Because that was x. Okay, so now we've set it up. Let's get x by itself. This is our third step. We're getting x by itself. So I'm going to go through all the steps. Eventually, I'm not going to go through all these steps with you. So we need to multiply both sides by the denominator, which is x in this case, and now x is canceled out. So now we have x times the cosine of 53 equals 6. Well, x is still not by itself, but what we can do is we can divide both sides by the cosine of 53. No, you cannot separate the COS from the 53. They are together. They are a unit. They have to go together. If not, they don't make sense. All right, and then that's going to cancel out the cosines. It's just like regular algebra, but with weird looking stuff. So now the x is by itself, and we're left with 6 over cosine 53. So in your calculator, you're going to put 6 over 6 divided by, hit the cosine button. It's next to the sine button under ABC. And I talked too much. What was that? 53. Okay, so we get 9.97. And if you're having issues with rounding, you can come over here to the gear, the settings gear, hit where it says float, and go to float 2. Okay, and that if you really can't get this whole rounding thing. So we're gonna click enter again, actually. Okay, oh, hold up. I don't like that. That is not working how it's supposed to. All right, so enter. There we go. So we have 9.97. All right, sorry about that. So hit float 3. 9.97. Okay, so I'm going to probably change that back because that's annoying. X equals 9.97. So that side is 9.97 units long. All right, now we have tangent. So tangent, we're going to, start by identifying where the hypotenuse is. And then we're going to find where the opposite is. So here's the angle in question. And this would be the opposite, right? Because it's across from that angle. And then this is the adjacent. All right, now we're going to take a look at the formula. So that's going to be tangent, and A is 40 degrees, right? Angle A is 40 degrees. And that's going to equal the opposite, which is 6, over the adjacent, which is x. So again, x is on bottom, so we're going to have to do what we did on that last example. Multiply both sides by x to cancel out the x. That's going to leave us with x times tangent 40, and that just equals 6. But again, x is not by itself, so we still need to divide both sides by tan 40, or tangent of 40. And that will leave us with, let me cancel those out. That'll leave us with x by itself. So that's x equals 6 over tan 40. This is all under the thing there. Okay, type it in, x divided by tangent 40, and we get 7.15. And again, my calculator is rounding this for me. Okay, so if I'm gonna change it back though, because it's getting on my nerves. I would rather not have to deal with that at all. Actually, what happens when I do a layout? Okay, it gives me a whole lot of numbers. All right. So yeah, this is definitely 7.15. Okay, so that's it. That's the first page of the notes. Let's go on to the next page. So again, make sure your calculator is always in degree mode. All right, now we have sine. Now this time we have to find the angle. So this is when you're looking for the angle. All right, I'm not going to go through what all these mean. It's the same thing. It means the same thing. So the angle in question is A because it asks us, it asks us to find the measure of angle A. So this is still the angle in question. Across from that angle is the opposite. And then this would be the adjacent. And I'm sorry, I should have done the hypotenuse first. Okay, and so now we just need to set up this equation. So this is going to be sine A. We don't know what A is, so we just put A, equals the opposite, which is 4, over the hypotenuse, which is 5. And we don't even need the adjacent side, kind of like on that first example. Okay, so this is different because A is over here. And let me just say this now because you might need to know. Usually we call an angle theta. It's like an O with a line going through the middle of it. So you might see this as well. It's just a variable, but it's a Greek letter, and it's called theta. So I'll just keep using theta, but it's just angle A. Okay, so in your calculator, what you need to do to get theta is take the inverse sine. So that's what it looks like. SIN with the little -1 looking exponent thingy, and then that'll calculate theta for us. So let's come over here. So what you're going to do is press and hold sine, and then this should pop up, and you want the first one, sine to the -1 power, and then 4 over 5, or you can just do 4 divided by 5, and there you go, get 53.13. And this is, oops, almost did that. This is in degrees because this is an angle. Theta is always an angle. So make sure you always use degrees. All right, for the next one, same old, same old. This is the angle in question. Oops. And we already know the hypotenuse is across from the right angle, so this is the hypotenuse. This is going to be our opposite side, and this is going to be our adjacent side. And now we're going to set this thing up. Don't forget the missing angle, right? Angle A, we're also going to call that theta. Just to get used to saying it, it doesn't really mean a whole lot right now. And we're using cosine theta because it's unknown, so we're just going to use the variable theta, equals adjacent over hypotenuse. So adjacent is 8, hypotenuse is 10. And then since we're working backwards, we're looking for the angle, theta is going to equal the inverse cosine of 8 over 10. And that's what we're going to type into our calculator. So hold, boom, you get cosine inverse, 8 divided by 10. You don't have to make it a fraction if you don't want to, just use the division, and then boom. 36.869. That 9's going to bump the 6 up to a 7. So 36.87. And this is again in degrees. Don't forget theta is always degrees because it's always an angle. Well, it's always an angle. It may not always be degrees, but it'll always be an angle. Okay, last but not least. So this is the angle in question. Let's go ahead and label this thing. This is, of course, the hypotenuse. AB is the hypotenuse. So hypotenuse for AB, this is going to be opposite, so, and this is going to be adjacent. And the hypotenuse doesn't even have a number on it, kind of like last time, the opposite didn't have a number on it, so we didn't even use it. So this time the hypotenuse doesn't have a number, so we didn't use it. And then for the first one, the adjacent didn't have a number, so we didn't use it. So it's kind of the same here. That's how you can tell which one to use when you're doing this by yourself. So this is going to be tangent theta, because again, we're using theta for the missing angle, equals the opposite, which is 6, over the adjacent, which is 12. And to get theta by itself, you're going to have tangent inverse of 6 over 12. So let's go ahead and do that over here. Press and hold tan. Want the inverse, 6 divided by 12, or 6 over 12 if you want to do the fraction, and we get 26.57 degrees. And that is that.